How's it going, class? This is Mr. Miles again. I'm coming at you with the last podcast before we have our big test on Thursday. So this is coming from lesson 5. This comes from lesson 5. This is all about plant responses and growth. So let's talk about this. Pretty easy chapter. Or not chapter, lesson. Goes over a few small things. Kind of cool when we're looking at the plants. So the first thing is tropism. If you're following on your book, you're looking at page 119, and the definition it gives is a plant's response toward or away from stimulus is called tropism. And so it's a response to stimulus. So it's a response to stimulus, and it can either be towards or away from that. Now, the three stimuluses that we're going to encounter that plants will react to is touch, it'll react to gravity, and it will react to light. So let's look at the first one under touch. So it's going to react to touch because sometimes weed plants would probably be the best, like if you have weeds or vines. If you put something near them, so like whenever your parents have like vine plants, they'll put up like these little gardeners, and they'll start down here and they'll connect with it, and then they'll start to weave their way up, and they'll go up like that. That's responding to touch. So now that it identifies that there's something there, it'll start to grow up it. Another thing is in the rainforest, you'll have certain plants that will actually send their vines up the plant or up the tree, and they squeeze around it really tight, and they actually try and break the tree and cause it to fall. That way, they can be exposed to more light, and so they'll actually go and be tree destroyers. Now, the other thing that we're going to run into is gravity. And in the picture that you see, it shows that if you have a plant tipped over, it won't continue to start growing out that way. Instead, what it's going to do is as soon as it's tipped over, it's going to start growing this way. It's going to curve back up. And the best way to think of that is think about if you've ever been hiking on a hill, and you notice that the trees, they're not growing out like this. Instead, what they're doing is you'll see them grow out a little bit, and they'll grow up. And they'll go like that, and they'll have that little bend in them. And they can actually, there's in the plant, it can sense gravity and which way is up, and it always wants to grow up because here is the sun, and if it's that way, it's going to be a lot closer to the sun than if it's growing out this way. You can see that. Remember, they always want to get as high as they can, as close as they can to the sun, because they're competing against other trees and other life in order to get to that sun. And the last one is light. And light's pretty cool because you can have plants grow in very odd ways. Now, if you're looking on page 120, you can see that picture that they have there where the plant isn't really growing straight like this, but instead it's actually growing out in that direction. So here's a plant, and it's growing out in this direction. And the reason is because it's sitting next to a window, and outside is the jolly Mr. Sun with his awesome sunglasses. And so it'll actually grow in that direction. Now, how this works, and you don't have to worry about this for the test, but it can be a little bit of good background knowledge that you'll run into when you take biology later in life, is auxin. Now, on a plant with the side with the sun, it'll have more auxin. And on the side with less, away from the sun, you can have less auxin. So what the plant does is it uses this hormone auxin in order to tell it to grow where there's more auxin. Because the auxin actually speeds up the growth rate. So if there's less auxin on this side, because there's less auxin because there's less sun, then this side's going to be growing a lot faster, so it's going to start to bow in that direction. And so what all these are doing is, well, what this is doing, and then what these first two, when you have touch and when you have gravity, is all being affected by something called hormones. And hormones, simply what it is, it's a chemical that affects how the plant grows or develops. And we have the same kind of hormones inside our body. As you hit puberty, your hormone levels increase in order to spark that change or that development. And plants will do the same thing as they're growing. Obviously, theirs is not the same as yours, but they still do have hormones like you do. Now, the other thing that you're going to run into, and this is what we're actually going to talk about tomorrow in lecture, is something called photoperiodism. And pretty much what this is it's a plant's response to seasonal changes in the length of night and day. And under this, they have something called a critical night length. Critical night length. And what a critical night length does is, if you're following on page 121, if you're not there, you might want to open up your book and follow along. You'll see you'll have a little chart where you have short day plants, long day plants, and neutral day plants. And you can see by however long the night is, so if you have a long night, then you have certain flowers that will bloom with that. If you have a short night, which is the second one under the long day plants, then you're going to have certain that'll bloom under that. And you have neutral ones, which just needs to be nice and neutral, even. Now, this is important because there's some plants that survive really good in the fall or winter time, and that would be your short day plants. And so they don't want to come out in the summer, because if they're more suited for cold weather, for less light, then they don't want to be coming out in the middle of the hot summer. And so they have this critical night length, and as soon as they detect that, the day is this short, then they'll actually bloom. They're not really going to be going off temperature, but they're going to be going off of how long the night is. And even with the summer ones, they're going to detect that, it's a short night, and I survive better in the summer, so now I'm going to start to bloom. And all this traces back to photoperiodism, where it is the length of day and night and the time of the year affects how they're going to grow and when they're going to grow. And the last thing we're going to run into today is dormancy. And this is actually a pretty easy one. Dormancy just means pretty much that it's going to stop growing. It's going to, when you're dealing with trees, they're going to turn yellow and red, and they're going to fall to the ground. It prepares itself for a long, harsh winter, and so they'll stop growing, they'll stop developing, they'll drop off things that they don't want to have to take care of, because keep in mind, it takes a lot of energy to take care of those leaves, and if the leaves can't do anything for it, if they can't be performing photosynthesis for it, the plant doesn't want it. So it'll just drop off the leaves because it can get new ones for the next year, and so that's what dormancy is. It's going into a state of rest. And getting ready to retire for the year. And not all trees and plants will do this. You have the evergreens that they don't drop off their needles and they just work as usual. But a lot of your leaf trees are gonna be doing that. So that is the last lesson. Pretty simple stuff. Remember, tomorrow's review, Thursday's a test. Hope you guys are ready for it. Should be a pretty good one. All right, until next time, take care. Bye.